The National Electrical Code, referred to as NEC, requires an equipotential ground grid for swimming pools, hot tubs, and other electrically energized bodies of water. The purpose of the grid is to establish a conductive path between the water, the electrical equipment, and the earth to minimize the risk of electrical shock. When a hot tub is installed on a concrete slab, the equipotential grid is typically installed in a specific way. Firstly, copper ground rods are driven into the earth around the perimeter of the hot tub, typically spaced 6 to 10 feet apart. Secondly, a bonding wire is connected to each ground rod. Thirdly, the bonding wires are connected to an equipotential grounding bar, which is typically located near the electrical panel. Fourthly, a bare copper wire is connected from the equipotential grounding bar to the metal frame of the hot tub. This wire ensures that the hot tub is at the same electrical potential as the ground grid. Fifthly, all electrical equipment, such as the pump, heater, and lighting, must be bonded to the equipotential grounding bar using additional bonding wires. The benefits of an equipotential ground grid are numerous. The grid creates a low-resistance path for any stray electrical currents, preventing them from passing through the water and potentially shocking bathers. The grid helps protect electrical equipment from damage caused by electrical surges or ground faults. The installation of an equipotential grounding grid is required by the NEC for the safe operation of hot tubs and swimming pools. It is always advisable to consult with a qualified electrician for the proper installation of the equipotential ground grid and hot tub wiring. The equipotential bonding grid is a critical safety component in hot tub installations. Its primary function is to minimize the risk of electrical shock by creating a common electrical potential throughout the area surrounding the hot tub. This means that if a fault occurs, any exposed conductive surfaces, including the water itself, will be at the same voltage, reducing the likelihood of a dangerous current passing through a person in or near the tub. The grid achieves this by connecting all metallic parts and any potentially conductive elements to a common grounding point. This includes the hot tub's metal frame, any nearby metal fences or structures, and even the reinforcing steel in the concrete slab. The NEC mandates specific requirements for the construction and installation of equipotential bonding grids. These requirements address the materials used, the size and spacing of conductors, and the methods of connection. The code specifies that the bonding conductors must be made of copper and be of sufficient size to safely carry any fault current. The size of the conductor is determined by the ampacity of the circuit feeding the hot tub. The connections must be made using approved methods such as listed bonding clamps or connectors to ensure a reliable and low-resistance connection. The location of the grid is also important. The NEC requires that the grid extend at least 3 feet horizontally from the inside walls of the hot tub and be connected to the earth through a grounding electrode system. This grounding system typically consists of one or more ground rods driven into the earth and connected to the grid with a continuous bonding conductor. The purpose of the ground rods is to provide a path for fault current to flow to the earth, further reducing the risk of electric shock. In addition to the general requirements for equipotential bonding grids, there are also specific considerations for hot tubs installed on concrete slabs. When a hot tub is placed on a concrete slab, the reinforcing steel within the slab can be used as part of the equipotential bonding grid. To do this, the reinforcing steel must be electrically continuous and be connected to the other elements of the grid with bonding conductors. If the reinforcing steel is not electrically continuous, additional bonding conductors must be installed to ensure that all parts of the slab are properly bonded. The installation process for an equipotential bonding grid typically involves the following steps. Firstly, the location of the hot tub and the surrounding area is assessed to identify all metallic parts and potentially conductive elements that need to be bonded. Secondly, the size and type of bonding conductors are determined based on the ampacity of the hot tub's electrical circuit and the requirements of the NEC. Thirdly, the bonding conductors are installed, connecting all identified metallic parts and conductive elements to a common grounding point. Fourthly, the grid is connected to the earth through a grounding electrode system, typically consisting of ground rods. Fifthly, all connections are inspected and tested to ensure that they are reliable and provide a low resistance path for fault current. The testing process typically involves using a low-resistance ohmmeter to measure the resistance between various points on the grid. The resistance should be low, typically less than 1 ohm, to ensure that the grid is effectively equalizing the electrical potential. Proper installation and maintenance of an equipotential bonding grid is essential for ensuring the safety of hot tub users. It is important to consult with a qualified electrician to ensure that the grid is installed correctly and that it meets all applicable code requirements. Regular inspections of the grid should also be performed to identify and correct any problems, such as loose connections or corrosion. By following these guidelines, you can help to ensure that your hot tub is safe and enjoyable for years to come. Furthermore, it is crucial to understand that an equipotential bonding grid is not a substitute for other safety measures such as ground fault circuit interrupters, or GFCIs. GFCIs are designed to detect even small amounts of current leakage and quickly interrupt the circuit, preventing electric shock. All hot tub circuits should be protected by GFCIs, regardless of whether an equipotential bonding grid is installed. In addition to GFCIs, other safety measures that should be considered include proper grounding of all electrical equipment, using only approved electrical components, and regularly inspecting the hot tub and its electrical system for any signs of damage or wear. It is also important to educate hot tub users about electrical safety and to warn them not to use any electrical devices while in or near the hot tub. The installation of an equipotential bonding grid can be complex, and it is important to have a thorough understanding of the NEC requirements and the principles of electrical safety. If you are not comfortable working with electricity, it is best to hire a qualified electrician to install the grid for you. A qualified electrician will have the knowledge, skills, and experience to ensure that the grid is installed correctly and that it meets all applicable code requirements. They will also be able to answer any questions you have about electrical safety and provide you with guidance on how to maintain the grid. In summary, an equipotential bonding grid is a critical safety component in hot tub installations. It helps to minimize the risk of electric shock by creating a common electrical potential throughout the area surrounding the hot tub. The grid must be installed in accordance with the NEC requirements, and it should be regularly inspected and maintained to ensure that it is functioning properly. While an equipotential bonding grid is an important safety measure, it is not a substitute for other safety measures such as GFCIs. All hot tub circuits should be protected by GFCIs, and other safety measures should be considered to further reduce the risk of electric shock. If you are not comfortable working with electricity, it is best to hire a qualified electrician to install the grid for you. They can ensure that the grid is installed correctly and that it meets all applicable code requirements. Remember that electricity can be dangerous, and it is important to take all necessary precautions to protect yourself and others from electric shock. Always follow the NEC requirements, use approved electrical components, and consult with a qualified electrician if you have any questions or concerns. By following these guidelines, you can help to ensure that your hot tub is safe and enjoyable for years to come. Another point to consider is the specific type of hot tub being installed. Some hot tubs come with pre-installed bonding lugs or connection points for the equipotential bonding grid. These connection points are typically located in the hot tub's metal frame or control panel. If your hot tub has these connection points, be sure to use them when installing the bonding grid. Consult the hot tub's installation manual for specific instructions on how to connect the bonding conductors to these connection points. If your hot tub does not have pre-installed bonding lugs or connection points, you will need to install your own. This can be done by using approved bonding clamps or connectors to attach the bonding conductors to the hot tub's metal frame. Be sure to select clamps or connectors that are compatible with the type of metal used in the hot tub's frame and that are listed for use in wet locations. When installing the bonding conductors, be sure to route them in a way that prevents them from being damaged or exposed to the elements. The conductors should be protected from physical damage, such as being stepped on or run over, and they should be shielded from direct sunlight and moisture. You can protect the conductors by running them through conduit or by burying them underground. If you bury the conductors underground, be sure to use direct burial rated conductors and to bury them at the required depth. The NEC specifies the minimum burial depth for electrical conductors, and it is important to comply with these requirements to prevent damage to the conductors. In addition to the bonding conductors that connect the hot tub to the equipotential bonding grid, you also need to bond any metallic parts or conductive elements that are located within 5 feet of the hot tub. This includes metal fences, metal handrails, metal gates, and metal light fixtures. The purpose of bonding these items is to ensure that they are at the same electrical potential as the hot tub and the surrounding area, reducing the risk of electric shock. To bond these items, you will need to install bonding conductors between them and the equipotential bonding grid. The bonding conductors should be sized according to the ampacity of the circuit that feeds the hot tub, and they should be installed in accordance with the NEC requirements. When installing the bonding conductors, be sure to use approved bonding clamps or connectors to attach them to the metallic parts or conductive elements. The clamps or connectors should be compatible with the type of metal being bonded and should be listed for use in wet locations. Also, remember to thoroughly inspect the entire equipotential bonding grid after it is installed to ensure that all connections are tight and that all conductors are properly routed and protected. Use a low resistance ohmmeter to measure the resistance between various points on the grid. The resistance should be low, typically less than 1 ohm, to verify that the grid is effectively equalizing the electrical potential. If you find any loose connections or other problems, correct them immediately. Regular maintenance of the equipotential bonding grid is also important. Inspect the grid periodically, especially after any work has been done on the hot tub or its electrical system. Look for any signs of corrosion, damage, or loose connections. If you find any problems, correct them promptly. By following these guidelines, you can help to ensure that your equipotential bonding grid is properly installed and maintained and that it provides the maximum level of protection against electric shock. Remember that electricity can be dangerous, and it is important to take all necessary precautions to protect yourself and others from electric shock. Always follow the NEC requirements, use approved electrical components, and consult with a qualified electrician if you have any questions or concerns. Finally, consider the specific requirements of your local electrical code. While the NEC provides a comprehensive set of guidelines for electrical installations, local codes may have additional requirements or may modify the NEC requirements in some way. It is important to be familiar with the local electrical code and to comply with its requirements when installing an equipotential bonding grid. You can obtain a copy of your local electrical code from your local building department or from your local library. You can also consult with a qualified electrician to learn about the local code requirements. They will be familiar with the local codes and will be able to advise you on how to comply with them. In addition to the equipotential bonding grid, there are other electrical safety devices that can be used to protect hot tub users from electric shock. These devices include ground fault circuit interrupters, or GFCIs, and arc fault circuit interrupters, or RFCIs. GFCIs are designed to detect even small amounts of current leakage and to quickly interrupt the circuit, preventing electric shock. RFCIs are designed to detect arc faults, which are a common cause of electrical fires. All hot tub circuits should be protected by GFCIs, and RFCIs may also be required in some areas. Consult with a qualified electrician to determine the specific requirements for GFCI and RFCI protection in your area. When selecting GFCIs and RFCIs, be sure to choose devices that are listed by a recognized testing laboratory, such as Underwriters Laboratories, referred to as UL. Listed devices have been tested to meet safety standards and are more likely to provide reliable protection. Install GFCIs and RFCIs in accordance with the manufacturer's instructions. The devices should be installed in a readily accessible location, such as near the electrical panel. Test the GFCIs and RFCIs monthly to ensure that they are working properly. The devices have a test button that can be used to simulate a ground fault or an arc fault. If the device does not trip when the test button is pressed, it should be replaced. In summary, there are many factors to consider when installing an equipotential bonding grid for a hot tub. It is important to understand the NEC requirements, the local electrical code requirements, and the specific requirements of the hot tub manufacturer. It is also important to use approved electrical components to install the grid properly and to maintain it regularly. By following these guidelines, you can help to ensure that your hot tub is safe and enjoyable for years to come.